What up, nerds? Welcome back to part 2 of our meteorology video lectures. Okay, last time we talked about air masses, intro to meteorology, uh, wind systems, and today we're going to be talking about fronts, pressure systems, and just more weather systems in general. Okay, so we're going to start with fronts. So a front is an area in which two air masses meet. So last time we talked about how air masses are generally just large clumps of air that are sitting over some part of Earth's surface, and that those air masses can be categorized based on both temperature and humidity. Okay, dryness versus wetness. All right. So what a front is when two of these air masses of usually of differing temperatures collide in some fashion, and the front is the boundary between them. So a lot of times people will see that probably most people are familiar with these shapes right here that you'll see on weather maps when you're watching the Weather Channel or something like that. But actual air masses are a little bit more 3D than that. They're a little bit more, uh, um, three-dimensional, so not as flat. But so we can see lots of different types of fronts, and we're going to go through each one individually, and we're going to be referencing back to this picture a number of times. So let's go ahead and get started. So first off, we're going to talk about cold fronts. Okay, so a cold front. These occur when a cold air mass runs into a warm air mass, and that forces the warm air to rise. So we talked about it last time. We've talked about it a million times. But one, again, of the most important concepts for earth science in general is the idea of density and of less dense warm fluids rising, whereas we have more dense colder fluids sinking. Okay, so a cold front, if you can see this picture, is going to have the cold air coming through, and because the warm air is less dense, it is going to be pushed up over top of the cold air and is going to come up here. Okay, now this causes cloud formation, since the warm air usually has moisture in it, and the moisture will then condense as it gets higher up to form these clouds, which we talked about during our atmosphere videos and our atmosphere units. And cold fronts, when they are shown on a weather map, will have, usually they're blue, but if there's no color indication, they always have these pointed triangles. Okay, and just as an example, okay, here's our cold front picture right here. So we've got a cold air mass coming through, and the warm air that's in front of the cold front, as the cold front comes in, it pushes it up over top of it and forces cloud development to happen. Okay, now a warm front, it's a little bit different. On a weather map, it's going to be usually indicated by a red line, but if there's no color, it will always have these little half circles, these little round shapes, okay, instead of the pointed ones. Now, a warm front is a little bit different, because a warm air mass running into a cold air mass will not make the cold air lift up. That's not how it works, right? Cold air is always going to be more dense. It's always going to stay down low. So what happens with a warm front is that the warm air mass will come and ram into the cold one, but then it will slide up over the top. But this still puts pressure on the cold air and still pushes it along as it does. Okay, so it slowly displaces it, slowly pushes it out of the way as it kind of slides over top. And you can see that here, right? So the actual warm air mass is moving this way, in this direction. The warm air hits the cold air mass, slides up over top of it, causes precipitation and clouds, and slowly the cold air moves out of the way. So we can see that again here. Okay, so the cold air is right here, and as the warm air from the warm front comes in, it pushes into it, it rises up above and slowly pushes it out of the way. Okay, and then there are a couple of kind of weird looking, or not, just more complex fronts. So a stationary front is when the two air masses meet and neither one advances. Okay, the air masses just kind of stall. You have light wind, maybe some precipitation, not much going on. Whereas an occluded front, this is where it gets really weird. Okay, so stationary fronts are going to have triangles and circles, but they're going to be going in opposite direction. It's like interlocking your fingers. Okay, an occluded front, and this is where it gets funky, is when you have one warm front going on. So you have a warm air mass pushing in on a cold air mass, but then you have another cold air mass that moves faster than the warm air and actually overtakes it, pushing the warm air up out of the way. And when this happens, you get an occluded front. Okay, and it's kind of hard to see here, but if you have an occluded front, it's going to have both triangles and little circles. But so looking at this here, right here is our occluded front. So you can see, again, triangles and circles moving the same way. Okay, so you have a warm air front that was coming in just like up here. Okay, and it was pushing the cold air out of the way, but then another cold front from that was much colder came in behind it, pushed the warm air up out of the way, and moved in on the slightly less cold air in front. So now you've got this kind of really weird weather system where you've got two different cold air masses, one colder than the other, and a warm air mass sitting on top of the two of them. Okay, so this is an occluded front. It's a little bit different, it's a little weird. Okay, but that's the basics of fronts. Okay, you will need to know all of these little weather shapes. Okay, okay. So now we're going to talk about pressure systems. Okay, so first we're going to talk about a high pressure system, and I mentioned this in our last video, but pressure, when we're talking about like air pressure, people get a little like they have trouble understanding what exactly people are talking about or what they mean, because you can't. It's hard to directly feel the effect of air pressure, whether it be high or low, but it is still there, right? So in a high pressure system, cold air is sinking and hitting the Earth's surface and spreading out. So if you're in the middle of a high pressure system, okay, what's happening is that cold air is falling towards Earth. It is directly sinking, and so it is putting more pressure on Earth's surface, is pushing down just a little bit more than normal stagnant air would. Okay, and that's what you can kind of see here with these lines. It's showing you how many millibars of pressure. Okay, so we're not getting a lot of pressure. It's not like crazy, but there is more. Okay, now in a high pressure system, when this pushing happens, a couple things are always clear. Okay, the wind blows away from the high pressure system, and that should make sense, right? It's hitting the bottom, hitting the Earth's surface, and spreading out. Okay, to either in all directions. High pressure systems have winds that go in a clockwise direction in the northern hemisphere. Okay, and generally they are associated with fair weather, and that should make sense because you don't have moisture accumulating up here in the atmosphere. You don't have a bunch of moisture hanging out up here. It's all coming down here and spreading out. So it's usually associated with very clear skies, sunshine, lovely picnic weather, usually higher temperatures during the day, lower temperatures at night. Kind of what we're experiencing right now in the middle of spring. Okay. Now, as the opposite, low pressure systems, okay, the air is rising. Okay. So it is actually being pulled up away from an area and spreading out in the sky. Okay, now this happens again because warm air is less dense, so it tends to rise above cooler air. Okay, now when this happens, we have a couple of things that we expect. Okay, wind is blowing towards the center of the low pressure system. Think of a vacuum. If you are sucking air out of one area, okay, well, air is going to need to come through to replace it. That's how a vacuum cleaner like you might have at home works, is that it creates suction and air has to rush in to fill that void, and so it gets sucked in. So you have the same thing here where wind is pushing towards the low pressure system right here in the middle. Okay. Usually this moves counterclockwise in the northern hemisphere, just the exact opposite of the high pressure, usually associated with clouds, precipitation, bad weather, because all of that moisture that is in the air here is going straight up into the air and causing clouds to form. Those clouds, once they have a lot of moisture, are going to get rid of it through precipitation, either snow or rain or whatever. So usually low pressure systems, you're going to see cloudy skies, low levels of sunshine, very wet weather, relatively mild temperatures. Usually it's kind of like not one extreme or the other, just kind of in the middle. Usually very windy, okay, and the weather can be pretty unpredictable in many cases as well. Okay, now there's this idea of cyclonic movement, and that just means this spiral movement. Okay, so the pressure systems that we just talked about, we got low pressure and high pressure. A cyclone is an area in the atmosphere that has lower pressure than the surrounding areas, and that spirals towards the center. That is what a cyclone is. Okay, it's like if like the drain in your tub or in your sink, it is cycloning because it's spinning towards the center. An anticyclone happens around a high pressure system because it's spinning away from the center. Okay, instead of circling down into the drain, it's going out as far as it can. Okay, and we see these differences in wind directions in lots of different places. We especially see them at fronts, as cold wind moves one direction, warm wind moves another. Okay, and so you can see something like this. This is especially where you get to see that cyclonic movement happening, is when the cold and warm air comes together. Okay, you got a warm air mass pushing past a cold air mass. The air is going to be moving in different directions, and slowly it is going to form this kind of cyclonic movement, and it's going to form a low pressure system, as you can see. Okay. All right, so there's a number of there we go. There are a number of weather instruments that we use to measure all of the different things that we talk about when we talk about weather and meteorology. Okay, some I'm sure you're familiar with, some less so. So a barometer, you may have heard of. It's an instrument used to measure atmospheric air pressure. Okay, that's a bar is the unit of measurement that we use for air pressure, or millibars. So a barometer is what we use for that. Okay, thermometers, I'm sure you're very aware of, measuring temperature using a liquid that moves up and down. Windsocks seem like a really silly thing to use, but are very, very important instrument to measure wind direction. Okay, very relatively sensitive depending on how you have it. And then this one, dare you to try to get this word right, is an anemometer. Okay, an anemometer. This is an instrument used to measure wind speed. These little cups will pick up wind moving in any direction, spin it around, and depending on how quickly it spins, we can measure wind speed. Okay. All right. And then beyond this, weather maps, when you're looking at a weather map, you're going to see a lot of different things. Okay, you're going to see these front symbols. You're going to see what these different fronts look like and different things. You're also going to see station models. Okay, so the station model is a really important shorthand that meteorologists use to know what the weather is like in a specific area. It tells you lots of different things: temperature, wind direction, wind speed, pressure, pressure tendency, cloud cover, dew point, current weather. Lots of things going on there. Okay, all of that can be shown all in one tiny little picture, just really, really quickly. And there are going to be several assignments that have you guys working on station models, so I'm not going to be going over that as much here. Okay, but the other thing we need to talk about with weather maps is right here, these isobars. Okay, so these are lines that connect equal points of equal pressure. Lines that are very close together, you're going to have strong winds because the pressure is changing very quickly. Lines that are far apart, the wind is going to be very light because the pressure is not changing quickly. So here, let me show you what I mean. So this line is 1024. That means that everywhere right here in this line is at a pressure of 1024 millibars. Okay, as you get away from that, everything in this line is at about 1020. Okay, outside of that, it's 1016, then 1012. Okay, now over here we have a low pressure system, which means the air is being, brought up and the pressure is going down. And you can see how quickly these are changing. 1008, 1004, 1000, 996, 992. Very, very quickly, very quick succession. So the pressure difference is very high and it's very close together. So you're going to be seeing very strong winds moving towards the center of the pressure system because it's low pressure, so the wind moves in and up. And that's it. Okay, so I hope you guys enjoyed these videos. Please make sure that you are contacting me with any questions that you have. Please make sure that you're doing the assignments that you're being um, assigned. But otherwise, if you have questions, you should know how to contact me. So until next time, be wonderful, stay curious. Gucci.